Now let's discuss model performance beyond simple metrics and introduce some ways to analyze it and improve it. To talk about model debugging, let me first focus on model robustness. Checking the robustness of the model is a step beyond the simple measurement of model performance or generalization. A model is considered to be robust if its results are consistently accurate, even if one or more of the features change fairly drastically. Of course, there are limits to robustness, and all models are sensitive to changes in the data. But there is a clear difference between a model that changes in gradual, predictable ways as the data changes, and a model that suddenly produces wildly different results. So, how do you measure the robustness of a model? The first and foremost thing is you shouldn't be measuring the robustness of a model during its training. Also, you shouldn't be using the same data set that you used during training. So before you start the training process, you should split the data set into train, validation, and test splits. You may use the test split, which is totally unseen by the model even during the validation stage, for testing the model robustness. Or otherwise, the best choice is to generate a variety of new types of data, and we'll discuss some of the methods to generate this later on. The metrics themselves will be the same types that you use for training, depending on the model type. So things like RMSE for regression models and AUC for classification. Let's take a look at ways to increase model robustness. Model debugging is an emerging discipline focusing on finding and fixing problems in models and improving model robustness. Model debugging borrows various practices from model risk management, traditional model diagnostics, and software testing. Model debugging attempts to test ML models just like code, very similar to how you would test in software development. It probes sophisticated ML response functions and decision boundaries to detect and correct accuracy, fairness, security, and other problems in ML systems. We'll discuss this more in a bit. Model debugging has several objectives. One of the big problems with ML models is that they can be quite opaque and become black boxes. Model debugging tries to improve the transparency of models by highlighting how data is flowing inside. Another problem is social discrimination. Does your model work poorly for certain groups of people? Model debugging also aims to reduce the vulnerability of your model to attacks. For example, certain requests can be made once the model is in production that may be aimed at extracting data out of your model in order to understand how your model has been built. This is especially a problem when data has private information and it's been used for training. So, was the data anonymized before it was used for training? Lastly, with time, your model performance decays as the distribution of incoming data changes. Three of the most widely used debugging techniques are benchmarking models, sensitivity analysis, and residual analysis. We'll discuss each of these individually.